So hey everyone, so welcome to another video. So in this video, I'll be explaining balancing redox reaction by oxidation number method. Alright, so here I have taken an example from NCERT, that is problem 7.8. So the question is, write the net ionic equation for the reaction of potassium dichromate with sodium sulfide in an acid solution to give chromium ion and sulfate ion. So there is a question. So how we are going to approach this question will be, so we have some steps, so we'll go stepwise. Total I'll be having 4 steps. Alright. So if you want to understand this, you better what you do side by side, you also write it so that it will be easier for you. Alright. So the first step we have is, we have to write the unbalanced reaction. So first step, write unbalanced reaction. Unbalanced reaction. So I'll write it on the right hand side here. So the first thing, writing unbalanced reaction. So from this question, we have potassium dichromate. So that is K2Cr2O7, which can also be written as Cr2O7 minus 2. And then we have sodium sulfide, that is Na2SO3. So here instead of Na2, I'll write it as SO3 minus 2 in an acid solution. So this reaction is performed in acid medium. So we have to balance this in acidic medium. And it gives chromium ion and sulfate ion. So this will undergo reaction and will form Cr plus 3 and sulfate, that is SO4 minus 2. So this is the first step, that is writing unbalanced reaction. Now once you have written this unbalanced reaction, in the next stage what you have to do, you have to find oxidation number. Okay, that is the next stage in this. So here we have chromium. So we know that this chromium, it is having an oxidation state of plus 6. Here sulfur is having plus 4. Here chromium plus 3. Here sulfur is having plus 6 oxidation state. So once you have identified oxidation number, next you have to identify oxidation and reduction. So in the next stage, you have to draw arrows. So draw arrows to indicate oxidation and reduction. So draw arrows to indicate oxidation and reduction. Alright. So here we have chromium, which is getting converted from plus 6 to plus 3. So this is gain of electron. So this will be reduction. Whereas sulfur is getting converted from plus 4 to plus 6. So loss of electron. So this is oxidation. Alright. So this is our overall first step. That is, first we have to write unbalanced reaction. So sometimes they may give question like this, or they may simply give the unbalanced reaction as it is. Alright. So first thing, write unbalanced reaction, then find oxidation number, then draw arrows to show where oxidation is taking place and where reduction is taking place. And arrows should go from left to right. Alright. So this is the first step. In the next step, what we have to do, we have to find oxidation number difference. So that is, find oxidation number difference. So before that, I'll rewrite this equation again. So which is Cr2O7 minus 2 plus SO3 minus 2 gives Cr plus 3 plus SO4 minus 2. So I'll draw these arrows. So this is where reduction is taking place and this is where oxidation is taking place. Now here, this chromium, see there are total 2 chromium here, but this oxidation state is of only 1 chromium. So basically here, 1 chromium is getting converted from plus 6 to plus 3. So if 1 chromium is getting converted to plus 6 to plus 3, so the difference for 1 chromium is 3 here. But since we have 2 chromium, the overall oxidation number difference for 2 chromium will be here 6. Alright. Whereas sulfur, there is only 1 sulfur here. Here also 1 sulfur. So 1 sulfur is getting converted from plus 4 to plus 6. So the difference here will be 2. Okay. So this is the second step where we have to find the oxidation number difference. Now once you have identified oxidation number difference, in the next stage what you have to do, you have to make these two numbers equal. So in order to make them equal, I can multiply with this by some numbers. Alright. So in the next stage, make oxidation number difference equal. So what I'll do, I will multiply this number by 3. So I'll get 6. I'll multiply this 6 into 1, which will give me 6. So by multiplying with the 3 here and 1 here, I am getting 6 on both the sides. So we have made the oxidation number difference equal. That is the second step. Alright. So once this is done, you have to go for the next step. So in the next step, what we have to do, so whatever the number we have multiplied here, okay, so here it is 3, here it is 1. So this number we have to add it on the left hand side of this arrow. So here this arrow ends here, so this 3 should be added here, whereas this arrow ends here, so we have to add 1 here. Fine. So that is the next step, that is add the multiplied number on left side of arrow. So this is our third step. So first I'll rewrite this equation. Cr2O7 minus 2 plus SO3 minus 2 gives Cr plus 3 plus SO4 minus 2. Alright. So here we have multiplied this by 3. So I'll add this 3 here. So here we have 3. Here we have 1. So I have to add it here. So anyway it will be as it is. Alright. So this is our third step. Now once you are done with third step, go for the fourth step. So in the fourth step, what we need to do, we need to start balancing atoms. Alright. So in the fourth step, you have to balance all atoms. Okay. So here we have to balance all atoms except oxygen and hydrogen. Except oxygen and hydrogen. Fine. So let us rewrite this equation. Cr2O7 minus 2 plus, so here we have 3, SO3 minus 2 gives Cr plus 3 plus SO4 minus 2. Alright. So we have to balance all atoms except oxygen and hydrogen. So here we have chromium. On the left hand side of this arrow, we have total 2 chromium. So on the right hand side, we have only 1. So to make it equal, I have to add 2 here. Alright. So chromium is balanced. Oxygen, leave it. Then we have sulfur here. On the left hand side of this arrow, we have 3 sulfur. Right hand side, there is only 1 sulfur. So we have to make sulfur equal. That is, add 3 here. So sulfur is also balanced. Oxygen, we can leave it for later. Alright. So in the fourth step, what we have to do first, we have to balance all atoms except oxygen and hydrogen. So once you have balanced all atoms, next what you do, you have to balance oxygen by adding water. So next, balance oxygen by adding water. So here on the left hand side, first we'll count number of oxygens. So in this we have total 7 oxygen. Here we have 3 3s are 9 oxygen. So in total on the left hand side we have 16 oxygen, whereas on the right hand side we have 4 3s are 12 oxygen. So in order to make number of oxygen same on both sides, what I need to do, I need to add water molecules. So here water molecules should be added on the right hand side, but how many water molecules we need to add? So total we have to add 4 water molecules. So now if you see, here we have 12 plus 4, total 16 oxygens. So oxygen is balanced. Fine. So here I have to add 4 water molecules. Alright. So once you have balanced oxygen, next what you have to do, you have to balance hydrogen. So next, balance hydrogen by adding H plus. So balancing hydrogen by adding H plus. So here left hand side there is no hydrogen, right hand side we have total 4 2s are 8 hydrogens. So we have to balance hydrogen by adding H plus. So that means on the left hand side we need to add total 8 H plus. Alright. So we have balanced H plus as well. So once this is done, this gives us the final balanced reaction in acid medium. Alright, so if you see here 8 hydrogens balanced, chromium 2 chromium balanced, oxygen total 16 balanced, sulfur 3 balanced. So all the atoms are balanced. Alright, so this is the final reaction, final balanced redox reaction in acid medium by oxidation number method. Alright, so I hope it is clear. Now see, the same question they may ask in basic medium as well. See, if they ask in basic medium also, the steps are almost the same. The only difference will be in basic medium you have to add one extra step, that's it. Alright, so now let us assume that the same question is asked in basic medium. So if it is asked in basic medium, what you will do? You will follow the same steps up to here. Fourth step it is same. In the final step, what we need to do? We just need to count number of H plus first. So if you see in this reaction, total number of H plus is 8. Alright. So in the final stage, what you will do? If it is given in basic medium. Okay. So this is only applicable if reaction or balancing should be done in basic medium. Okay. If basic medium is given, then what you do? First count number of H plus. So in this reaction total we have how many H plus? 8 H plus. So after counting, what you do? You just add same number of OH minus. Same number of OH minus on both sides. On both sides. So let us apply this rule in this equation. So I'll rewrite this equation. See here. So instead of rewriting, I'll just copy this. Duplicate. So yes, so we have this reaction. So what I need to do here? First you have to count number of H plus. So in this reaction total we have 8 H plus. Then what I need to do? I have to add same number of OH minus on both sides. So since there are 8 H plus, we need to add 8 OH minus on the both sides. So here I will add 8 OH minus. On the right hand side also I will add 8 OH minus. Done. Next you see, here we have OH minus and H plus. So these two can combine and we can simply write it as 8H2O. So water molecule. Now you see, on the right hand side we have 4 water molecules. Left hand side we have 8 water molecules. So we can cancel them. So here 4 water molecules, and from here 4 water molecules will be removed. So on the left hand side 4 water molecules will be remaining. So if I write the final reaction here, so it is 4H2O is remaining on the left hand side plus Cr2O7 minus 2 plus 3SO3 minus 2. Okay, I'll write here like this, gives 2Cr plus 3 plus 3SO4 minus 2 plus this is removed and remaining is 8OH minus. So this becomes the final balanced chemical reaction in basic medium. Alright. So this reaction is in acid medium. So if the question is asked in acid medium, you just have to stop here. But if the question is asked in basic medium, you just need to add one more step here. That's it. Alright. So this is the balancing redox reaction by oxidation number method. Alright. So we have discussed balancing by oxidation number method. So we'll also discuss balancing by half reaction method. Alright. So in half reaction method, so this is the question we need to balance. So here the first step we have is the same thing, that is write unbalanced reaction first. Write unbalanced reaction. So we have this reaction anyway. I'll keep it as it is. So after writing the unbalanced reaction, next you have to find oxidation number. Now once you determine oxidation number, next you have to draw arrows to show oxidation and reduction. So draw arrows to show oxidation and reduction. So this step is same in both the cases. Alright. So here this is the reaction we have. So instead of writing, I'll just copy it. So first step is write this unbalanced reaction, then identify the oxidation number. So here manganese is plus 7, bromine, this is minus 1, this is plus 4, and here we have plus 5. So second thing is identifying the oxidation number, then you draw arrows to show oxidation and reduction. So here manganese is getting converted from plus 7 to plus 4, that is gain of electron, which is reduction, whereas Br, this is getting converted from minus 1 to plus 5. So this is what? Loss of electron, so it is oxidation. Alright, so this is the first step. Now once this is done, next what you have to do, you have to split this reaction in half. So since this is a half reaction method, what we need to do, we need to write separately a reduction half reaction and oxidation half reaction. So what I'll do, I'll make two columns. So on the left hand side, let us say I'll write oxidation half reaction. On the right hand side, I'll write reduction half reaction. So this is reduction half reaction. Alright. So here the oxidation half reaction is Br minus getting converted to BrO3 minus. So Br minus gets converted to BrO3 minus. Whereas reduction half reaction is MnO4 minus gets converted to MnO2. Alright. So once you have written this, next what you need to do, you need to start balancing atoms. So here, second stage, balance all atoms except oxygen and hydrogen. So here, if you see here, we have what? 1 Br, but here also we have 1 Br. So in this case, we don't need to do any changes. So I'll rewrite this equation as it is. So Br minus gives BrO3 minus as it is. Whereas in this case, there is 1 manganese here. Here also we have 1 manganese. So no need of any change here as well. So we can write it as it is. Now once you have balanced all atoms except oxygen and hydrogen, next what you need to do, you need to balance oxygen by adding water. So balance oxygen by adding water. So here we have 3 oxygens on the right hand side, so we need to add 3 water molecules on the left hand side. 3 water molecules on the left hand side. Whereas here we have 4 oxygens on the left hand side, here on the right hand side we have 2. So in order to make oxygen equal, we need to add 2 water molecules on the right hand side. So we have balanced oxygen by adding water. So once this is done, next what we need to do, we need to balance hydrogen by adding H plus. So here left hand side we have total 6 hydrogens. So we need to balance it by adding 6 H plus on the right hand side. Similarly here we have 4 hydrogens on the right hand side. So I need to add 4 H plus on the left hand side. So this balances the atoms. Alright. So what we have done here, first thing you have to write the unbalanced reaction, then find oxidation number, then draw arrows to show oxidation and reduction. So this is understood. Now once that is done, next what you need to do, you need to split this reduction and oxidation half reaction. So you have to write it separately. So I have written oxidation half reaction on the left hand side, reduction half reaction on the right hand side. Done. After that what we need to do, we need to start balancing all atoms except oxygen and hydrogen first. So since there is no change here, we had written it as it is. After balancing all atoms apart from oxygen and hydrogen, we need to start balancing oxygen by adding water. So once you have balanced oxygen, next you have to balance hydrogen by adding H plus. Alright, so this is the second step. Now once this is done, next what we need to do, we need to count electrons. Alright, so we need to balance charges basically. So in the third step, balance overall charges. Overall charges. So for that what you need to do, first you need to count the overall charges on left hand side and the right hand side. So here this water, it is neutral, so it is 0, whereas this Br is having -1 charge. So on the left hand side of this arrow, minus 1 charge is there total. Whereas here on the right hand side, if you see, overall this BrO3, it is having minus 1 charge. See, here we are talking about overall charge. So overall BrO3 is having minus 1, whereas one hydrogen is having plus 1. But since we have total 6, so total charge will be plus 6. So plus 6 minus 1 will be equal to plus 5. Now what we need to do, we need to make this overall charge equal. How we are going to make that is, we just need to add 6 electrons on the right hand side. So if I add 6 electrons, see, one electron has minus 1 charge, so 6 electrons will have minus 6. So overall charge on the right hand side will become how much? Minus 1, which will be same. So in order to balance overall charges, what I need to do, I need to add 6 electrons on the right hand side. So first I will rewrite this equation, that is 3H2O plus Br minus gives BrO3 minus plus 6H plus. Now in order to balance overall charges, we are adding 6 electrons here. Alright, so if you see minus 1 on the left hand side, so here plus 6 minus 6 will become 0, minus 1 will remain. So charge is balanced. The same thing you have to perform for this reduction half reaction as well. So here first you count the charges. So one hydrogen is having plus 1, 4 hydrogens will have. So plus 4 minus 1, this will be equal to plus 3. Whereas here MnO2 it is neutral, water it is neutral, so overall on the right hand side it is 0. Now in order to make both sides equal, what I can do, I can add electrons on the left hand side. So if I add 3 electrons, so minus 3, this will become 0. So what I need to do here, I need to add 3 electrons on the left hand side. So that will be 3 electrons plus 4H plus MnO4 minus gives MnO2 plus 2H2O. So you see 3 electrons minus 3. So here we have minus 1. So total overall charge is minus 4 plus 4, 0. On the left hand side it is 0, right hand side also it is 0. So what we did here, we have balanced overall charges by adding electrons. So this is the third step. Alright. So once you have balanced the overall charges by adding electron, next what you need to do, you need to make these total electrons same. So in the oxidation half reaction we have 6 electrons, in the reduction we have only 3 electrons. So what I need to do, by multiplying overall this reaction by some numbers, I need to make these 2 electrons same, so that when I add these, combine these 2 reactions, both of these electrons should get cancelled. Alright. So in order to make them equal, what I can do, I can multiply this entire reaction by 2. So if I multiply by 2, 3 2s are 6 electrons. So here also we have 6 electrons. Alright. So what I'll do, I'll multiply this one by 2. So multiply into 2, whereas this one into 1, or as it is we can keep it. So when I multiply this by 2, we get here 6 electrons plus 4 2s are 8H plus 2 MnO4 minus gives 2 MnO2 plus 2 2s are 4 water molecules. Done. So this gives us the reaction. So next what do? You just need to finally combine both these reactions. So the final step is combine both half reactions. So here oxidation half reaction, first I'll write 3H2O plus Br minus gives BrO3 minus plus 6H plus 6 electrons. Whereas here this is a reaction, that is 6 electrons plus 8H plus 2 MnO4 minus gives 2 MnO2 plus 4H2O. So this is oxidation half reaction, this is reduction half reaction. So we just need to combine them. Now when you are combining, you just see whether you can cancel anything or not. See here on the left hand side of the arrow we are having 3 water molecules. Here on the right hand side we are having 4 water molecules. So what I can do, I can cancel these 3 water molecules here. So 1 water molecule will remain as it is. Next, left hand side we have 6 electrons, here also 6 electrons, they get cancelled. So here we have 6H plus, so here we have 8. If I cancel 6, 2H plus will be remaining. So apart from this, I don't think anything we can cancel. So after cancelling, you just write the final reaction. So whatever is present on the left hand side of these arrows, you just write it on the left hand side, and whatever is present on the right hand side, write it on the right side of the arrow. So here on the left hand side we have Br minus plus 2MnO4 minus plus we have 2H plus here. So these are present on the left hand side. So on the right hand side, BrO3 minus plus 2MnO2. So these are the things, plus 1 water molecule is remaining on the right hand side. So this gives us the balanced redox reaction by half reaction method. Alright. So this reaction is balanced in what? Acidic medium. So if suppose this question is asked in basic medium, what you have to do? You just have to add one more step. The step is you count number of H plus and then you just add number of OH minus on the both the sides. So the same step which we have studied in oxidation number, that you have to apply here. So when you apply, basically what is going to happen? So if I add 2 OH minus here and 2 OH minus here, what will happen? 2 water molecules will get cancelled, this will get cancelled, and 1 water molecule will remain on the left hand side. So if I just write the reaction in basic medium will be 2MnO4 minus plus H2O gives BrO3 minus plus 2MnO2 plus 2OH minus. So basically this gives us the balanced redox reaction in basic medium. Right? I'm not going to do that step. You can just refer it from oxidation number method. It is the same. Alright. So make sure to read the question properly. So you see whether the reaction is given in acidic or basic. Based on that, you can start answering the questions. Alright. So I hope half reaction method is clear for you. So if there are any doubts, you can just comment in the comment box. I'll try to answer there. Alright. So that's it for today's video. See you in the next video.